Welcome back, everyone. As usual, use cameras, please. If you have the possibility to turn on the cameras, could be great. For today, first, some people ask me about the midterm, so I would like to let you know the schedule for your midterm, Wednesday, March 10. So as I mentioned, the week 9 of the semester. Before the midterm, my plan is the lecture before, do a full review. I am going to let you know the most important topics, but remember, it's comprehensive, so everything from the lecture 2 until the lecture previous to the exam. The exam online during the lecture time, so you are going to have 1 hour, 15 minutes to complete the exam, mostly multiple choice questions, a couple of them open programming. I am not going to ask you to draw diagrams. However, the multiple choice questions are going to have diagrams, and most of the things that you're going to need to write in your exam is source code, and probably source code equivalent to a particular diagram that we provide. So I am going to give you more details, but by now, put on your calendar March 10, the midterm. Good? And you have plenty of time to prepare. Now, for today, you finished your assignment. You did this lexical analysis to identify tokens, categories of words from a string, something that you write in a graphical user interface. In the previous lecture, I asked you, how do you solve the problem? Common solution, the naive solution, the easy one, if-else conditions. We have this program, and I have these inputs, and I need to provide this output, and its classification. If-else. If this one, else the next one, else the other one, and so on. Problem with that. The problem is you get a cyclomatic complexity that is high. You have more than 10 conditions easily. If you have more than 10 conditions, you need to split your method, the one that is identifying the different tokens, in different methods. Probably you did an effort to provide those methods with a good name. So if someone else needs to review your source code and try to modify something, like include a new category of token there, hopefully that person could navigate your source code and found the correct method to modify. The correct thing, the place to add or remove something and evolve the software. You know what? In general, the problem with your solution, the problem with these if-else switch cases, the number of conditions in your software increase the level of difficulty of provide maintenance to that software. In general, this is from a paper, 2008, it's not really new. However, the idea kind of similar. The probability of you having some kind of bug, problem, failure in your software, if you have methods and that methods follow cyclomatic complexity of 10, for this study in particular is if you reach 11 conditions in any of your methods, that give you a probability of 28% of an error. It's not really low, but looks not so bad. However, 40 conditions, 50-50. 50% of probabilities that you have an error. Just for the conditions. We're not talking here about the rest of your software, the graphical part, the controller, the listeners, the tables, other things. Just having a mistake in how you are classifying the tokens Less than 100, 74. And it's almost sure that the software will have an error. I could ask you, how many conditions do you have in your solutions for assignment 2? The only thing that I know, you are above 11. Most of you, most of the solutions that I reviewed. %30 of probability for errors, above. It's not exactly a good solution. When you have a problem and your problem involves so many conditions, like your assignment, it is time to search for a different design for the solution, for a different approach. Nesting if else, switch cases, is not exactly something that should be your only option. It is great for less than this, less than 10. Okay. More than that, another approach. Now, the question here is, for sure we have more than 10, a different approach, which is another approach that could replace all the if-else that you have. And someone mentioned this in the previous lecture, well, we can go and use regular expressions. That is true. Regular expressions can help you, but the global picture, what is a regular expression? Regular expression is just a fancy way to represent a tool that is behind of the regular expression, that is powerful for this kind of problems with conditions. And that tool is state machines. Probably you remember these guys from the state machine diagrams in UML. We're not talking about the same. I am not talking about the diagram per se. I am talking about the tool that provides origin to the diagram. State machine diagram. State machines, very simple thing. You want to identify something, and instead of asking if something, instead of this case, 3 ifs, one inside of the other, you define the model, the diagram, the behavior that you want to represent in a picture. That picture can be translated to a table. Instead of using instructions, if else, what we're going to use is an array of data. The array is the one that is going to control the conditions. We're going to have an array of data controlling the flow of execution of the program. It is better to have more data. It is better to have an array and just access the array to know what to do instead of having a long list of several if-else. One if-else alone is easy to read. A bunch of 100 if-else is boring. And those things that are boring are hard to read because the people is not going to put attention. And if the people do not put attention, the people is going to make mistakes. That is the problem. Okay, you could be thinking like, and how this diagram and this table can solve the problem that we have in the assignment. Oh, I give you one example and then we move to the full solution. One example, I remember that I asked you one thing. Can you identify binary numbers? Can you identify just reading that something is 0, B, and then binary numbers? If you want to identify something like this, the state machine tell you, well, we're going to start in 1 point. And if you read a 0, you have something. After you read the 0, if you read the B, you can move and have something. After you read the B and you have something, here you can have a 0 or a 1, a 0 or a 1, and move forward. And you know what? You can continue having zeros or ones, and you stay there. And you stay there, and as long as you are in this S3, what you have is a binary number. If in any moment, here, or here, or here, you have something else, a number 2 here, or a letter, or a dot, anything else, you have an error. Yeah, remember that the goal is to create the longest word possible. So if I have here a number 2, or if I have here a letter, those are not the limiters. I am not going to put anything. I am going to put those letters and those numbers together with the things that I have before. And all this is going to be an error. If I use this state machine with only those 4 states and with those connections, programming this, I can provide a string, an input, and the program that implements this state machine is going to be able to identify binary numbers inside of the string that I provide as an input. Okay, but that is the diagram. Tell me, what I do to program this diagram? Well, very easy. You have a 2D array, and in your 2D array, number 1, the rows. The rows, you are going to have 1 row per circle, 1 row per state. This here, states. The states, the same that I have as a circles in the diagram. I have 4 states, okay, my 4 rows, and I add the error, another one for the error. 1 row per circle. 2, what about the columns? In the columns, the inputs. Things that I am going to use as an input, or if you want to think about it, my connections. Input, 0. Input, the B. Input, the 1. What happened with a letter, with a number, with anything else that is not 0, 1, or B? Okay, 1 column for everything else. Everything else. If you want to create several columns for B, C, D, 1, 2, 3, other things, you can do it. Or you can have just 1 column, and this column apply for everything that is not B, 0, or 1, because those I have it already. And the only thing that you do is, well, you know what? If I am here, what happened when I read a 0? Okay, you are in the state 0, and you receive a 0 as an input, current state, and my input. The intersection of those two, what I should do, move to the state 1. And everything else, if I am here and I receive a 1, if I am here and I receive a B, if I am here and I receive whatever else, all of them are errors. My diagram is only to identify binary numbers. If you think about it, well, if I am here in 0 and I receive a 0, probably this is going to be a full path to identify octal numbers. If I am here and I receive a 1, probably this one is a full path to continue and review integer numbers. If I am here and I receive a letter, probably this one is going to be a full path to identify identifiers. You start in one point and you draw a line for whatever you could read, and you decide if that whatever is going to be a full branch of research or is just, this is an error. I know that it's an error. I am going to go to the error and I am going to stay hitting the error until some condition. State 1, if you are here and you receive a B, move to the next one. But if you are there in S1 and you receive 0, 1, or whatever, anything else, errors. Similar with the 2, if you are here, you receive a 0 or a 1, move to the next one. Whatever else, errors. You are here, and if you continue receiving 0s and 1s, stay there. It's a binary number. You can continue receiving 0s and 1s as many as possible. Anything else is an error. You are in the error, and it doesn't matter what do you receive. Continue with the error. Well, one more column. One more column. What happens if the input is a delimiter or an operator or a white space or a quotation mark for the strings or for the characters? Do you remember that all of these are the characters that code a string? The operators, the delimiters, the quotation. Those are the things that you use to code things. Well, if I receive any of them, use stop. Stop. Because you already have the classification for one word. It's an error, maybe. It's a binary number, maybe. But any of those delimiters, operators, and so on, stop. Stop. Tell me what do you have. And then after you tell me what do you have, go back to 0. Start again with the next word. Did you notice the process is just a repetitive process? Start in 0, process characters until you found one of these, report what do you have, start again. Programming. If you think about this diagram and this table in the source code in Java, what I basically have is I need these columns, and the columns represent B0, 1, something else. The only thing that I can use to access an array are numbers. I have the column 0, the column 1, the column 2, and so on. Do you remember constants? What about having a constant B, 1, 0, others, delimiter, error, and so on? I can use these ones just to follow with the design, but they have a numeric value. They have a numeric value because I want them to be the coordinates of a 2D array. Thinking about the 2D array, this one, and a static private array, and even final, because it's not going to change, is the programming representation of this guy. And you can notice S1, S2, S3, S3, all those numbers, the number of the state is basically the number of the row, right? If I am in the state 0 and I read a 0, go to the state 1, go to the state 1. Well, this is the state 1. In my program, this is my row 0. The first thing is an error. The second thing is column 2, state 0, go to 1. Error, error, stop. 2, errors, stop. And so on. Is the table to the array of integers with all the knowledge of how to identify binary numbers in this case. Now, what I do with this, what I do with these constants, and what I do with this array of states, something like this source code. All the things that you have, those if else that you create to identify if is the limiter, if is binary, if is octal, all those different methods can be replaced by something like one loop. Let's do a loop. And this loop is going to be running while there are letters in the line. You have a line, and we're going to do a traversal from the first element to the last one in that line, from the first character to the last character. And what are we going to do? Read the letter, and with that letter as an input, calculate the next step. What does it mean? Yeah, which is your current state? By default, you can start with 0, just like in my example. Tell me, if you are in this particular state, initialization is 0, and you have this letter from the row, tell me, which one is the next state? You go to your table, use the row and the column as the coordinates. You get the intersection. And that one is your next state. My next state. And whatever was the letter that you used to do the transition, concatenate that letter with the previous one. Because what you're doing is to create a word, one letter at a time. Letter, 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 concatenate that. And for each character, just move to the next state. Move, 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 move. In some point, you're going to stop. When you're going to stop? When you read an operator, a delimiter, and so on. And when you stop, this loop is going to end. When the loop ends, you have two things. One word, and you are in one state. And that state is going to tell you what is the category of the word that you have. For instance, in my example with the binaries, the only thing that I am going to do is to check, okay, the current state. The current state is 3, yes or no? If the current state is 3, here in this implementation, if I am in 3, I just have a correct binary number. If I am in any other place, 0, 1, 2, error, what I have is an error with a binary number. I have a binary number that could be used 0B with nothing else, or I could have a 0B with ABC. I do not know. I do not care. If I am not in S3, it's a wrong binary number. So if I am in 3, I can do whatever I need to do to tell the computer, good, You have a binary number. If I am not in tree, I can notify an error or put an error as a category for the word that I just read. That's it. Now, also, if the current character that I have, remember, it could be a delimiter, a white space, a tab, an enter, or could have been an operator or something like that, a quotation mark. So I need you to fix that part. I just need to be sure that if I have an operator, well, I need to report that I have the binary number and the operator. If I have a white space or a tab or something else, that's it. The only thing that I have is the binary number. I can ignore the space and so on. But if I have an operator or a quotation mark, I need to use that one for the next word. So something needs to be done in the source code just to be sure that the operator or the quotation mark is going to be used. After that, go to the next line. Go to the next line. You can put this in a loop, or you can use recursion. If you use recursion, at the end of a method, you can call the method itself, and the only thing that you need to do is give me another line. Another line, if you read all your program in one string, like you can do it with your graphical user interface, the one that you create, the only thing that I am going to do is to send as a parameter now the line, the original one, minus the characters at the beginning that I already processed. In some point, I am going to send as a parameter an empty string, and when I send an empty string, this process is going to stop. This is the only thing that I need to solve the problem that you solve with the if-else. What do you need to do in order to extend this solution, not only for binary numbers, but for all the categories that I asked you to consider for your assignment too? Do we need to change something here? And if so, what? Can you agree with me that the only thing that you need to be worried about? Exactly, thank you. The only thing that you need to be worried about is, well, go to the theoretical background. In the theoretical background, the only thing that we need is, if you already showed me how to identify binary numbers, and that identification of binary numbers is complete outside of the programming, I can define what are the tokens that I want to identify. And I do not need to talk with someone that has programming skills. I do not need to talk in terms of regular expressions or in terms of a particular instruction in a library in the language that I am using. Moreover, I do not need to talk in terms of if-else and the bunch of if-else that we have. What I can do is to define this state machine, these transitions with my stakeholders. It's like, let's check. I am going to be here, and you're asking me to identify a particular category of words. Tell me, how do I know which word is one particular? Remember all these examples that you asked me to solve, all the examples that we reviewed during the lectures or that you have in the slides? It's like something like this. What if I receive a 0? What if I am reading something like X equal 0xff? What if I read something like that? Well, you are going to start reading the first character. The first character is an X, and you are here, and you just read an X. So what is going to happen is that you're going to move here. You're going to read the next one, and you're going to read the next one, and the next one is an operator, and just because the next one is an operator, you are going to stop according with our table there, and you're going to stop. And when you stop, what you have is X, and you are in the state 3, and let you call the state 3 ID. But also you have the operator, this one, right? That operator make you stop. So you have the operator, and it's an operator. Remember the condition before? It's not a delimiter, it's not a quotation mark, it's an operator, so that one is an operator. You can put an if else if you want to identify which kind of operator, in which category this operator is. 2 ifs, 3 ifs. And what happened then? Then you return to the state here to 0. Remember the loop? Go back to the 0. Okay, I go back to the 0, and then, well, and then you are reading this character here, the 0. Okay, I have the 0 and I am in the state 0. Yes, what I do? Move here because you just read the 0. Okay, and then read the next character, the X. Okay, I am in 1 and I just read the X. Oh, there is a path for that. Move to the 6. Okay, I am in 6 and now read the next character. I read an F. What I do? Move here, you read the F. And now read the next one. Another F. Another F. Okay, I stay there. What next? Oh, that is the end of my line. This is kind of an enter character there. An enter character, I am going to stop. I am going to stop, and the word that I have is this 0xff, and I am in the state 10. And we just can call the state 10 an hexadecimal number. Each of these states that I put the circle in orange around are kind of good states. If you are here or here or here or here, it's like you have something good. If you are here or even here, you have something that do not have any meaning, any classification. Therefore, all of that are errors. And moreover, from all of the circles, if you receive something that is not there, the assumption is you move to an error state. If you are here in 9 and you receive something that is not 0 or 1, any other thing, to the error. You are here and you receive something that is not any of these, to the error. But usually you do not put that one because it's a lot of lines to one circle, but it's just obvious. If you receive something that is not there, something that is not shown in the machine, you move to the error. Did you notice that this thing is working even not only for binary, but now variables, operators, and hexadecimal numbers? The only thing that I need to do is to define the full machine, the full set of states, and all these different combinations about what can happen. What is the meaning of receiving a 0, and then after receiving the 0, receiving numbers from 0 to 7? I think this guy is octal numbers. What happened if I receive the 0 and then the X and then something else? Hexadecimal numbers, identifiers, integers, floating point numbers. You can check the circles and you are going to notice which is the combination that corresponds to the pattern for that particular category. And when you read the patterns, what do I have, what is next, and so on. And even the loops, I am sure that that result familiar. Regular expressions. With regular expressions, you build the state machine. The good news, if you build the state machine by yourself, you can translate the machine to a table with states, the rows, columns, your data, and the only thing that you need to define is the result. The result that could be an error or the next step, the next state. With this one, these columns and these inputs, you can create something like this, more or less. the different inputs, the different states. And there, do I need to change something in the program? I change the table. I add more constants. The machine, the table of states, is more complex. It's going to change the source code that I already explained to you. This source code is going to change. The same source code can be used with this small machine that is identifying binary numbers, or with this one identifying every single token in a program. Yeah. Now, I show you this part here, and here in this paragraph, the only thing that I am considering is I read a character, and that character could be a delimiter, or could be an operator, or could be a quotation mark. Something that should be done there in that paragraph is to consider special cases. And one of them is the one that you're asking on the chat. It's like, well, what happens if you have, yes, the variable, but then what happens if you have an operator, this one, and it's an operator with two characters? What happens if you have an operator, but you cannot assume that it's just one operator with one character, because it will be an operator with the next character also be part of the operator? How long can be an operator? We know that it could be one or two characters, right? There are no operators with three. So there is something that you can do here when this is true, and read the next character and check if the next character is also an operator that you need to put together with the one that you already have, for instance. It's a special case, it's a special validation. Operators with two characters is something that we need to do here. 3 more lines, and we have the source code for operators with multiple characters. Well, I am not asking you to use that one, but even if we want to use that one, read one character, check if it's an operator. If so, concatenate and do while, put that process in a loop. So do that again and again and again, so you can concatenate operators of any size. My point is, worst case scenario, what you need is a loop and an if. You increase the complexity in 2 units. Which is the complexity of the source code that I am showing you here? Cyclomatic complexity. Below 10, right? Below 10. And you know what? In one method, with cyclomatic complexity lower than 10, you solve the problem. When you are doing a design, the important thing is think about the solution, a solution that you can share with the stakeholders. And usually a good solution is not exactly something that needs you to use complex data structures. Do not check your hash tables and sets and things like that like your first option to solve something. It's not going to be. Neither creating a long program with a lot of conditions or a lot of loops is usually the best solution, neither the only one. With this, one method, complexity below 10, and you can replace with this all the things or several of the things that you use in your assignment. Which solution is easy to explain? Which solution is easy to fix if something failed? A bunch of if-else that you need to remember which one is doing what. Several methods checking different things that you need to remember what you are returning. Or something that maybe not like this, but like this. You can show to the stakeholders and explain your idea. You know what? What we are doing is identifying the categories of the words, and what we are doing is this combination is called a binary number, or this combination is called an integer number, or whatever. One of the main problems that you have in your assignment is that you ask me for test cases. One of the main things that happen is that a test case that you didn't think before, something new, something that you didn't test, make your software crash. If you do this diagram, there is no way that you do not consider all the possible combinations. All the combinations are there. Not a particular example, but all the possibilities. Questions, guys? So read the file, read character by character, concatenate characters, move the states, and repeat until you have all the words. Programming. The class token. Do you need to change anything in your class token if I ask you to implement the solution that I showed you? Your class token is going to change something? Anything in token that is different in order to move from the solution that you have to the new one? And hopefully your answer is nothing. Tokens, the same. Lexer. If I give you the source code for a class Lexer, this one, and just to be sure that you read it, if I give you this source code, that the only thing that these do is to identify binary numbers. The source code there is only for binary numbers. This is the source code for the first example that I showed you, the one with the small table. If I give you the source code for the Lexer that is able to identify binary numbers, is this screen, and this screen, and this screen, and this screen. Well, question in the chat, what do you do to use only one if condition to identify binaries? Did you call a method is binary? Or you have a regular expression? If you have a regular expression, basically your regular expression is the same thing that I am showing you, but instead of doing the table and the states, the regular expression represents that. The try catch is just part of the program, right? To identify errors. But your regular expression is the tool that you have in the libraries to create this. You can put this as a regular expression. Obviously, create a regular expression for this one. It's very simple. Create a regular expression for this one. Probably is not going to be as simple as the previous one. Which solution is most simple? the regular expression or the table with the array? As usual, it depends what is your expertise with regular expressions. In terms of the performance, in terms of what the software, the computer is doing, is exactly the same. A regular expression is basically something that inside is creating the state machine. You are asking for a state machine using the language of the regular expression. If you are experts with the regular expression, if you want to create your state machine using regular expression, again, for identifying only one thing, like only binaries or only numbers or things like that, is very easy. When you want to put together several regular expressions or create a regular expression for all this, it's not going to be so easy. And if your solution is create independent regular expression, one regular expression for each of the category, it is better to create this and one table that represents everything. So one loop, as I showed you before, that have all these regular expressions that you are checking. Not only for the performance, but also for the complexity. If you are not able to create one regular expression for all of this, then you are not expert in regular expression, then you are creating a small regular expression for a small parts, performance. And explain to your customer this, or even this could be easy, that explain to your customer, your stakeholder, what is the meaning of this regular expression that you are showing. In terms of validation, in terms of team working, again, depending on who are you working for, the table could be easy. But again, at the end, this one is a regular expression, a big regular expression. Now, if I give you the source code for this, and I already showed you the lecture is 100 lines. My question to you guys is, how many lines did you create in your lecture? If you use regular expression, hopefully less, but for some of the homework that I review, you have twice, I mean, 2 times or even 3 times this number for the lecture, because all the if-else. If I give you 100 lines of code working, and I ask you to implement the solution that I show you, what do you need to do in this source code in order to make this work, not only for binary numbers, but for everything, for all the categories that you create for your homework? Do you need to change something in the source code? Do you need to change something in the methods? Or is just the data that should change? Hopefully, you agree with me that your instructions, the loops, the ifs, the variables that you have, they can be the same. There is only one thing that you need to change. What? If, by any chance, for the assignment 3, I ask you for more or less categories, if I decide to make the binary numbers in a different way, or the floating point numbers, or if I want to include complex numbers, whatever change the customer asks you, with an approach like this, the only thing that you need to do is someone in your team modifying this table, not the source code. And if you think about it, when you have a source code and you do not need to change the instructions, the only thing that you need to change is the data, that is the configuration of that source code. You do not need a programmer for doing this. The only thing that you need is someone in your team, and if you want, try again and again and again and again with different configurations until the input and the output match what you need. And that is good. What if I give you the table? What if I told you, this is the table, the state machine, the full state machine for everything that I asked you to do. Everything is there. How many columns? How many rows? Can you move from this, that is the source code, to the diagram? What do you need to understand this table? The rows are irrelevant. Hopefully you agree with me. What you need, the important thing, the columns. What if I told you that those are the columns? Column 0, 1, and so on. Constant for the columns, the full table. And these states represent exactly the same thing that you did. This table with these constants inside of the Lexer Java. Could you make this work? I am not asking you to do this from scratch because I am going to ask you to do another thing for the assignment 3. However, I do not want to just give you the source code and everything is done because I would like you to understand what you're doing. So half and half. I give you the source code from a previous version and I give you only the table and the constants for the final version. Can you make it work? Put things together and create a version of the Lexer with this and this, applying the idea that I just explained to you. And that is the version 2 of your assignment 2. Make sense? Silence. That is yes, no, maybe. Okay, 1 yes, 2, 3, good. Okay, guys, this is the part number 1 of your assignment 3. For your assignment 3, the first thing that I want you to do is to move from whatever approach you use to this approach. Because tell me, what is going to happen with this approach, the table, later, when I change the categories? Hopefully, as I mentioned before, the only thing that we're going to do is modify state here. Any change is possible. Good? Homework. I am not asking you to submit anything. It's going to be part of your assignment 3. We're going to talk about assignment 3 next week. So for this week, you do not have a homework to submit for programming. However, I am giving you 1 week, your only programming assignment so far, this. Move your implementation from assignment 2, whatever you did with the if-else, to state machines. You are going to need this for the assignment 3. So start working. Same people that work in the assignment 2, move your source code to this approach. Any question, let us know. You need this for the assignment 3. If you do not start working like this week, later, you're going to have a lot of work for assignment 3. So the sooner that you can start, the better. Good? Questions about what to do? Hopefully clear. Yeah? Silence. Good. Okay. Moving forward. For your assignment 3, something that I am going to ask you to do is use patterns. And previously, we reviewed the observer pattern. By now, you should be able to implement the observer pattern, both the original one from scratch and using the Java API. For your exam, I am going to give you both options. I am going to ask you for the observer, up to you if you follow or use the libraries in Java, or you decide to implement everything from scratch. But remember the pattern. Moving forward, I have some minutes. I want to explain another pattern, a small one, Singleton. Previously, we reviewed this observer. In which category is observer? Creation, structure, or behavior? Can we agree that it's behavior, right? My behavior is observing you. So observing is a behavior of an object. Being the one observing or being the one being observed. It's about the behavior of two entities. Good. Maybe the most common pattern in the behavioral category is observer. If you do not know any of the others, at least as an engineer, it's mandatory that you know what we are talking about when we mention the observer pattern. Similar way, I need to talk about the assignment 3, depending on how fast we move. Probably I talk about that in our next lecture, or I am going to talk about that next week. In any case, after I present the assignment, you have 1 week to work. So best case scenario, if I do not finish this week and I introduce the assignment next Monday, you're going to have 1 week starting next Monday. So you still have time. My only thing is for the assignment 3, I am going to ask you to use the state machine model for the lecture. So I am giving you time to start working on that. So that's it. But I need to introduce assignment 3 later. Good? So patterns. Observer is the easy one from behavior. The easy one for creation is the Singleton. Singleton, let me be clear. All the patterns related with create, they are about create objects. And in order to create objects, the options is you want to create one object or more. You want to create the object in one step or in several steps. Different patterns cover those 4 scenarios. For the Singleton, as you can imagine, Singleton, I want to create one object, only one object from a particular class. I have this class, whatever you imagine is the name of the class. And from this class, I only want to allow in the full system to have one object from that particular class. No more than one, only one. Can you give me an example in which circumstances in a system you only want one object from a particular class? Exactly my question in the chat. Why only one object? When do we want only one object? What could be the circumstance in a system in which we do not want to allow more than one object? What if, think about a system, and in a system, you have an object Imagine a scenario in which in your software, in your system, for some reason, there is a class representing something like a source of data, something like the register office in the university, something like a particular database, something like a particular intelligence engine or something like a sensor connected with the system, you have a class for that. You have a class that represents a data source connection. You have a class that represents the registrar office. You have a class that represents the database. You have a class that represents a sensor. In a particular scenario, in the real life, you only have one sensor. You only have one database. You only have one intelligent engine. A particular scenario. You are developing the software for desktop application, and you are developing the software for an enterprise thing. In the desktop application, you only allow one. In the other, maybe more. But in a particular scenario, you want to be sure that under no circumstance, there can be more than one object. Why? If you think about the example with the database, if you create more than one object, and both objects are representing the same database, if you use one or the other, because they are representing the same physical thing, you can have problems. You can ask this one to write and you can ask this one to read, and they are doing opposite things. If you have only one printer or one sensor or one physical device or whatever, and you create two objects, the system can think that there are two printers or two sensors or two devices just because you have two objects, but they are connected with the same physical device. The correct thing to do is to have only one. Moreover, to avoid a programmer to make the mistake of creating more than one, there are two scenarios. You can just be nice and tell to your team, students, please, from this class, create only one object. Do not create more. And you know what is going to happen? Someone is going to make a mistake and someone is going to create more than one. Asking in a nice way do not work. The thing that you need to do is if someone creates more than one, that should be a compilation error, period. The thing that you need to be sure is if someone do not follow the rule, the consequence is going to be a compilation error. Why a compilation error? Because we do not want the system to fail in runtime. We want the things to fail when the programmer is working alone in the computer. So these are examples of scenarios in which you create a class and you want only one object to be able to be created. Okay, what can I do to be sure that there is only one object from a particular class? Which instructions in Java are connected with the idea of one and only one variable? Okay, you mentioned the key ideas. If you have a class and you want only one object, or you want to limit the creation of objects from that class, there are three things that are going to happen. And those are the three things that you need to identify in this pattern. Number one, how many objects can you create from a class, a normal trivial class? If I give you a class, a student, professor, or whatever, how many objects can you create from that class? As many as you want. Good. Why? Because you can use the new operator. The new operator is going to call the constructor of the class. Remember? Can I do something to avoid you using the new operator? Can I do something to avoid you to do new from my class? Hopefully you notice this is the template, the class diagram for that pattern. Feature number one in this pattern: make the constructor private. Professor, the constructor should always be public. That is something that they told me in my 110 class. When I learned to program in Java, all the constructors public. Yeah, all the constructors public. When you want as many objects as possible to be created from that class, you make your constructor public because you want the people to create objects from your class. You make constructor for a student public, constructor for professor public, constructor for computer public, because you want the people to create object, professor, computer, students, and so on. If you want to limit the number of objects, if you do not want to allow the people to create objects from your class, easy solution, make the constructor private. If your constructor is private and someone do what is going to happen with this instruction in this class? My constructor is private. This line is going to compile. It's going to be a compilation error. Compilation error, that is exactly what we want. I am going to share my class with you, and I want to be sure that you do not create more than one object. Step number one, my constructor is private. If you try to use my constructor and you try to use the new, as usual, you're going to get a compilation error, so you cannot create objects. Professor, we want to allow one. Okay, if we have the new, they are going to create n. But just doing the constructor private, now you move to 0. So from n to 0, but you should allow one. Okay, next step. Next step, if the constructor is private, no one can use the constructor outside of the class, right? What do? I need to provide a public method. A public method that is going to replace the constructor. Replace the constructor is going to be a method. Usually, that method is going to be a getter, as you mentioned in the chat. Again, it's just a method. It's a method, and that method is going to do the same thing that usually the constructor do. It's going to be a method that usually is called get instance. Again, it's use a name. It's a method that is going to replace the constructor. And it's the method that I can call when I want to create an object from that class. Now, tell me, what do we need to do for this second line to work? There are two things. Number one, my method is going to be public. The name of my method in my example is get instance. No parameters. What the method is going to return. Did you notice that I have a class? The constructor of the class is private, and I have a method that is public, and that method that is public return an object from the class. Return a singleton because the class name is singleton. Remember, the name can be a different name. Should not be singleton mandatory. It's just a class that have a method, and that method return an object from the class. Moreover, in order to call the method, just because right now I cannot create objects from the class, I cannot trust that I'm going to be able to call the method using an object. If I am not able to call the method using an object, my other option is to call the method using a class. And if I am going to use the name of the class dot the name of the method, that is the call for an static method. This guy is an static method. okay? But you only want to return one. So if I have a class, public class, database, you are telling me that I should do private database. It doesn't matter that it's empty, but I do it private and no one can create objects. But then you are telling me to do a public method, and that public method should be static, and that method should return an object from the same class. But if I just return here whatever I want, I can create n objects. But I do not want to create n, I just want to create one. Can you imagine an if-else condition that could help me with that? And someone in the chat already helped me like, well, you can use a variable, and in that variable you can store an object, and if that variable is null, you create a new object. But if you already have a value in that variable, the only thing that you do is to return the variable, so you are sure that you only have one. Now, that variable inside of the class, I need a variable, but I am going to modify that variable inside of a static method. What happened with that variable? Should also be static, right? You cannot modify a variable in a static method if the variable is not static. Static method, static variable. The variable is going to be private. And if you think about the source code, you are telling me that we're going to have a class database. You are telling me that you are going to do private the constructor. You are telling me that you need a variable. And is all of that from the same class. The variable need a name. It doesn't matter really the name of the variable. Usually instance, I am going to use I. And you need a public method that return the object. And basically, you are going to check if that variable is null. If the variable is null, can I do that? In this example, can I call the new and obviously call the constructor then? Tricky question, right? Yes or no? Good catch. Now, can I call the constructor with the new, even though the constructor is private? Can we agree that the private is going to limit the constructor to be used outside of the class, but inside of the class, in this particular method, I can call the constructor and this is going to work? Okay. So if the variable is null, now it's static, I am going to create the object. What if the variable is not null? This is the full plan for the Singleton pattern. This tells you that you have a class. The name is Singleton for the example. In this one, database, it doesn't matter the name of your class, but if you have an instance variable private, static, if you have the constructor private, and you have a public method that inside basically have an if condition, as you check if you have the instance variable null or not, and if it's null, create a new one, but if it's not null, return that one. What you have is that you are sure that for a particular class like this one, there is one and only one object in the full system from that class. Good? Clear? Yeah, this one and this one, both static, so you can make the call with the name of the class. Thank you. Okay, guys, I am going to stop here. See you next lecture. Thank you.